All right, so this is LeetCode 15. It's called threesome. So given an integer array nums, return all triplets nums of I, nums of j, nums of k. Basically, they want us to return an array of these values such that none of the none of the positions are equal to each other, so they're all distinct, and that when you add all these values, they're equal to 0. And then with the caveat that the solution set must not contain duplicate triplets. So we can't have an array that has maybe, like, let's say our triplets were 2, -1, and -1. We can't have this repeated again in our output. We can't have 2 of these in our output like this, right? Because they don't want duplicate triplets. So we would have to get rid of one of these or write our solution so that it doesn't allow for these duplicate triplets to be inside of our solution. Okay, yeah, so let's look at the example here. So example 1, the nums array is this. As you can see, it's not sorted at all. And there are duplicate values, so -1, -1 are the same. There's only duplicate values in here. But our output would be -1, -1, 2, because this comes out to being -2, plus a 2, which comes out to being 0, which is what we want, right? And then, so this is why this is one valid triplet, and then -1 plus 1 comes out to being 0, right? And then plus another 0 just comes out to being 0, which is our valid triplet. So these are 2 are valid triplets, and they're not duplicates, right? They're not both the same. Okay. So I think before we get into explain how to do this, it's probably be a good idea to go back to twosome here, and then also twosome2 to see how we solve those problems, right? So in twosome, we solved it using, and go back to these videos if you're interested, if you want to get like a deeper dive into a deeper explanation. But basically, twosome, we calculated a complement, and then we sacrificed on some space. So we used a hash set, right, or just a set to keep the complements. So we sacrificed on space and used a set, right? Twosome2, what we did was we knew that our input array was sorted. So and then the problem said that they wanted us to I think they wanted us to write it where we had no extra space. So they wanted to make it so that we didn't use any extra like data structures to keep space. So we used a left and a right pointer, which gave us the time complexity of n, big O of n, but constant space. And the way we were able to get it down to big O of n was because we knew that our input size was, our input array was sorted. So we can just use the left and the right pointer to just move the values to get closer to our target. And I'd watch the video on that that I just uploaded to get a better sense of that. But yeah, so so going back to here, as you can see, it's just in all of these problems, like LeetCode has like a tendency of just building up on previous problems and just adding a little bit more complexity. So basically, this isn't that much different than the last problems. The last two problems, twosome and then twosome2, are pretty much inside of this problem, but as sub-problems, right? This just has a little bit added layer of complexity. So let's run through like maybe like a naive solution. Let's imagine we have -1, right? This is our first value, so we have like a pointer here. say this is P1, so we have -1, and then we want the three values to add up to 0, right? So then now that we have -1, to make it so that all three values add up to 0, we want the next two values to be this value, but without the negative sign, just the sign flipped, right? So we have -1 plus, and then we have two extra values. This is right like an equation, plus these two extra values is equal to 0. We want this outcome, right? So this problem here results is just basically two-sum, right? We would want to find two numbers that add up to not -1, but this number with its sign flip, so it would be +1. So we would look for two numbers that add up to +1, which could be 0 and 1, right? Which gives us this output right here, because 0 and 1 add up to +1, which is the opposite of this number, which gives us our 0, right? This solution is a little flawed because as we get down here, we can get duplicate triplets. So what we're going to do to actually make it so our solution doesn't keep duplicate triplets is we're going to sort this array, right? So we're gonna let's sort this array. So let's say that this array is, I'm gonna type it out so it's a little easier. It's gonna be -4, -1, -1, 0, 1, 2, right? This is what our sorted version of this array is going to be. So automatically, if you know about sorting algorithms, I believe the time complexity is O n log n. So automatically, our time complexity is going to be this, right? So, oops, I'm looking at the wrong one. So this is automatically going to be time is O of n log n, right? Because we have to sort the array in ascending order. Okay, and then now what we can do is basically look here, and we can just have, you know, the same thing that we did before, P1 be equal to this value, and then what we can do is basically do the same thing that we were doing before. We can just calculate 2 sum 2. Now we can just make the rest of the array be 2 sum 2, which is basically using a left and a right pointer. A left and a right pointer, right? So our left and our right pointer are going to be at the beginning of the rest of the array after our P1 value. And our target is going to be let me do this let me type this out, it's a little easier. Oops. Target is equal to opposite, or almost not opposite, it's going to be P1 times -1, right? It should, or in other words, I think you can just say it as being the opposite. So it's going to be, in this case, it's going to be -4 times -1, which is 4, right? And the reason why we're doing this is because we ultimately want all these three numbers in the triplet to add up to 0, right? That's what our valid output's going to be. Okay, it's a mouthful, but hopefully you're following. So we've sorted it. We've got the O of n log n time, and then we're going to use 2 pointers. So this left's going to be here, and our target is going to be 4. So -1 plus 2, what does that give us? That gives us, right now, I'm just basically repeating what I did in the 2 sum 2 problem. So -1 plus 2 is 1, right? How does this compare to our target? -1 is less than 4. And since we know that we just did the work to sort our array, we know that this is an ascending order. We can use that information to make this solution a little faster, or to smartly move our left and our right pointers. So because we know that this is our current sum, this is like our current sum right here, cur sum. This is our current sum, and then this is our target. Since we know our current sum, which is the left and the right pointer added together, we know that it's less than our current target. Then what we can do is just move our left pointer over. So now it's going to be this value. But these two values are the same, so we can just disregard them and then move them again. Move the left pointer here. Okay. 0 plus 2 is 2, right? How does 2 compare to 4? It's the same deal. It's less than, so we'd have to move the left again. Left right here. 2 plus 1 is 3. How does that compare to 4? It's still less than. And then we've reached the end of the list, so that we know that we're not going to have any triplets that include P1, right? Now we've reached, our left and our right pointer have reached the end of the list, so we're good. And then we can just move our P1 value over. So this P1 value is going to go over here. So now our P1 value, I'm going to do it in a different color. P1. So this pink represents the second iteration. I probably should have typed it out, but oh well. This is our second iteration, and our blue is the first iteration. So this P1 is always going to have to move from, it's going to have to touch every value, right, basically. Every value up to, I think, maybe not all the way to the end, because we need a triplet, so I think it's going to go maybe up to like right here, and then stop. We'll have to figure that out while we code it out, but now our P1 is going to go here, and we're going to continuously do the same process. So we're going to have our left and our right pointer here. Okay, and now our target is 1 because it's the opposite of -1. Okay, and then we're going to run the same process. I'm not going to go through it because I think you kind of understood it from what I did before. But yeah, that's the algorithm we're going to do. So we're not going to use any extra space. Our space complexity is going to be, O of 1. It's going to be constant. Because even though we are using some variables, hopefully you can see that that's a 1. O of 1. So it's just constant. We are using extra variables, but these variables aren't going to scale as our input size grows, so they're just some pointers. But the biggest time operation that we're going to do, or the biggest like taxing operation that we're going to do, is the sorting, which we can use Python's built-in sort function, but under the hood it uses log n time complexity. And you can learn that by just watching some other videos about what's like the best what's the best time complexity for sorting. But yeah. All right, so let's get into the coding solution. So before we get into it, again, I want to reiterate that we're going to use sort of this kind of process. So it's going to be, we're going to have a P1 pointer, so we're going to have a loop that this P1 is going to always kind of touch every value, right? And then plus the result of this right here, which I'm doing in this pink color. This is going to be the result of, this process right here is going to be the result of 2 sum 2 on the rest of the array, which is going to give us our two other values from our triplet, basically our valid triplet. So yeah, so let's go ahead and try to write this out. So we're going to have one loop, so for P1 in range, length of nums, right? And then I'm trying to think that I think if we have a triplet, or if we're generating triplets, then the last position P1 can be is probably this third from last position, right? So I think that what we can do is length of nums minus length of nums. Let's say that the length of this is 6, right? So instead of being 6, 6 minus 1, we do 6 minus 1 minus 2, I think. Which would be, in this instance, it'd be 6 minus 2, which is 4. This is the 0 at the next 0, 1, 2, 3, 4, which, and I think range is exclusive, so it would be the third. This would be the last time that P1, this is the last position P1 can be at. So that's why we're going to use a negative. We're going to do length of nums minus 2, because since we're generating triplets, we only want P1 to go to this last third from last position. Okay. All right, so now we're going to do a loop with inside which where we're doing our 2sum2 calculation. So let's look back here just for reference. So we're going to use a left and a right pointer, right? Okay, so we're going to say left is equal to P1 plus 1, and then right is going to be equal to nums of it's going to be the length of the nums. It's going to be the end of the index, or the end of the array, right? So it's going to be length of nums minus 1. Cool, because we want the right index always to be at the end right here. It's going to be this position here. And then what we're going to do is while left is less than right, non-inclusive, because we don't want to use the same position. We don't want to have this equal sign. We want to make sure it's just strictly that these left and right pointers don't overlap, right? While left, and then what we're going to do is we're going to calculate our current sum. So current sum is equal to we're going to do our left value above here. We're just going to do it in a variable so that it's a little easier to understand instead of writing it all in one line. So this left value is going to be equal to nums of left. And then honestly, we can probably just, I think I did this in my other video too, where we can just call this left position, or even maybe a little easier to understand, maybe left index and then right index. Just substitute these. So left value is going to be equal to nums indexed into left index, which is when I say index into, I'm just meaning these brackets right here. And then right value is going to be equal to nums of right index. Okay, cool. And then we could have calculate our current sum, which is just equal to left value plus right value. Okay, and then we're going to have a couple if statements. So if current sum is less than what our target value, right? What's our target value? Our target value is going to be, in 2sum2 we were given the target value, but in this instance we have to generate that target value. So it's going to be the opposite of P1, right? So it's going to be nums of P1 times -1, which is basically going to flip the sign, right? So if current sum is less than target, then what we're going to say is current sum is less than target, then what we can do is, I believe we can move our left pointer, because since we know that our array is sorted, moving our left pointer over to the right is gonna increase our current sum, which is gonna get it closer to target. And again, this is the same process as 2 sum 2, so go ahead and watch that and I give a better explanation of what I'm doing here. So if current sum, then we're gonna do left index plus equals 1, elif current, in the other situation where current sum is greater than target, then what we need to do is basically decrement our right index, because if our current sum is greater than the target, then we know that moving our right pointer over to the right would just increase our sum, which is getting farther and farther away from the target. And since this part of the array is sorted, we know that moving the right point over to the right would just give us, it would be impossible to find the target, so we need to move it over to the left, which is basically decrementing it. And then otherwise, or else, this is the situation where current sum is equal to a target. Then in this instance, we found our left and our right index are at the right values to find our sum of 0, our triplet sum of 0. Then what we can do is just have an output array, and this is going to be equal to just a normal array. Before I forget, we're just going to, outside of the loop, we're going to return output array, right? And then, there we go. And then here, we're just going to append to the output array. So output array dot append. Well, it's going to be p1, comma, left index, comma, right index, right? And that's going to be our triplet, because in this situation where we get to else, we have our p1 from our first loop, then we've done, this loop basically does 2 sum 2, so then in this instance where our current sum is equal to our target, which is the opposite of not wherever p1 is at, we're going to have our triplet, and these values are going to add up to 0. Cool, and I think everything's pretty much in here except the logic that is making it so that we don't use, like, say that we don't use like -1 and then -1 for p1 right away. So we're going to say that, all right, so like I said, we want to make sure that p1 doesn't use, if p1 is next to a duplicate p1, so say that this was, say p1 was at this -1, we just finished that loop, we found a triplet, and then p1 went directly over to this -1. What we'd want to do is we want to make sure that doesn't happen, that there's no duplicate triplet. So we'd want to have a check here to say that if p1 is equal to not p1, but if nums of p1, so the value at that position is equal to nums of p1 minus 1, so the previous one, if they're equal, then we can just skip it. We can just continue. We can just skip this iteration of the loop. And to make sure that this doesn't cause any issues on maybe if we're at the first iteration of the loop, or we would get index out of bounds if we were at the very first iteration of the loop, we want to make sure that p1 is greater than 0. Yeah, greater than 0 for p1. And if p1 is greater than 0 and this, then we can continue. Let's see, we never sorted it actually, so I think actually nums.sort just does it in place, so we don't need to do that, so we can just do this. Oh, looks like something's wrong. Okay, I think I know where the bad thing is. We're doing the output array and every iteration of that for loop, so we're going to want to do it out here. That's at least one mistake. Okay, another error that I just found is that I think this return or output array has to be outside of this for loop. It was inside of the for loop, so we want to do it when everything is done. We want to do it when both of the loops are done, not just when the while loop is done. Looks like there's still another error. So typically, I think that with these interview problems, I think there's a point where you don't get enough value by just trying to figure it out, by just banging your head against the wall by looking at this. I think this is one of the helpful tools to help you kind of know what's going on. So I copied the code here, pasted it in here, and as you can see, there's some like classing stuff that you need to get rid of. So I got rid of that. So like the classing and the type information. So got rid of self. I got rid of this type annotation and the output or the return value annotation. Got rid of that because Python Tutor doesn't like that. And then what I do is I just basically copied and pasted this last executed input and then ran it against our function here. So 3sum. And then I walk through it. You can walk through the steps of where the code is. So this green line is the line that just executed. The red line is the line that's going to execute next. So you can see what your variables get initialized to. So we sorted our array. We have our output array. Here, I already see that there's one problem. We're appending we're appending the indices and not the actual values at those positions. So I made an alteration. So I did I stored p1 value into this variable here, and then basically I'm appending. Previously we had the left index and right index, so I just changed this to the left and right value, which we're storing up here, which is the actual values at that index. So that's one problem that we fixed. And then here, as you can see, we've reached almost like an infinite loop. Here, this while loop is going to run forever because our current sum is equal to the target, is always going to be equal to the target in this scenario. So, and we're never, in this else statement, we're never moving left or right index. So this condition is always going to be true. So we need to move this left index or the right index, but we're just going to move the left index. So we're going to do, after we append it, we're going to do left index plus equals 1. And I believe that should get rid of that little edge case, so we can even add it in here. But I'm going to go ahead and copy this. I'll just show you what I do. So I see, like, there's often times where like the bugs that you encounter with these types of problems are just really too hard to understand without a tool. So, and this is the prep situation. We're prepping, right, for interviews. So, so let's go to run this again. So now you see in the previous situation, we had like, it was step 1 of like 8,000 if you go back a couple seconds in the video. Now we've got only 96 steps. So yeah, I highly recommend this Python tutor. It helps a lot. So here we go. We can walk through. We see we ran the num sort array, nums.sort, then we went to the loop. And let's see. It looks like this is right. Let's go ahead and just run it on LeetCode to see if we get the right output. Okay. So now we didn't account for this situation. Okay, I think what we're not accounting for is we're accounting for this line right here is basically not allowing duplicate p1 values, right? Which is basically our first value in our triplet. But this value, this right here, this loop right here, which calculates our left and our right index, or our 2 other values in our triplet, allows there to be there's a possibility where this left index could have duplicate values. So I think here in this else statement, we need to, and to better visualize that, basically what I'm saying is, like, if we look up here in this example, I'm writing in the pen. Let me do it like in a color we haven't used, so let's do it in green. So imagine this is P1, and then this is going to be left and right. So automatically we found a triplet, right? 0 plus 0 plus 0. We found one triplet, so we're going to add that here. I'm going to move this left value over. So now we have P1 plus 0 plus 0. So this while loop here allows us to have a triplet because we're not checking for if these left values can be continuous duplicate values. So here we need to add a check to make sure that left doesn't equal the same left value that we previously calculated. What we're going to do is we're going to have an if statement here. We're going to say if nums at left index is equal to nums at left index minus 1. So basically this equates to being the previous index or the previous value. And then we want to also make sure that we haven't crossed our boundaries, so our left and our right index haven't crossed. And left index is still less than right index. Then what we can do is basically say we want to just append or increment our left index. So this will hopefully get rid of the situation. This will get rid of the situation where left is next to the same left value. So we don't have a duplicate inside of that. Let's see if that gets rid of that. Oh boy. Alright, so I paused the recording and just messed with this a little bit, and I got it to work. So the only change I made was I changed this condition from being an if statement to a while, and I'll explain why it actually made the change. So let me go ahead and erase this right here. So this is the test case that we're failing, right? So we have the input of this, and then this is the output that our algorithms, our solutions giving, and this is the expected. So automatically we can see that there's a duplicate. These two triplets are duplicates. And the reason being is because there's multiple, our left value can be here. There's multiple, when we do our two-sum calculation on this subarray, our left value is basically adjacent to the same value 3 times. This is 3 negative 2's, right? So instead of having just one condition where we just say if this is the case, then when we move our left index to the right, we want to do this while that's the case. So while our current left value is equal to the last left value and that we're still in bounds, we want to just continuously increment our left index so that this two-sum 2 calculation, which is on the rest of the array, this part right here, so that it keeps highlighting everything else, so that this right here, which is highlighted in green, not including the negative 4, so that this part of the array doesn't have any duplicates in it. I hope that made sense, and I hope this illustrates that solving these types of problems, you go through a lot of iterations, trials and iterations, and I always make jokes that I think LeetCode has the worst test case or the worst edge cases, but in reality, I think this is how it is in real life. You gotta think of all the edge cases. So again, let's go back to the time and space complexity. So the time complexity would be we are using n log n to sort it, right? But we're gonna have two loops, right? We're having this p1 loop, which is gonna go to this is just gonna be O of n. In the worst case scenario, it's gonna bubble out to being O of n, and then this is also gonna be O of n, right? This loop is negligible, so our overall time complexity is going to be O of n squared, and then our space is still going to be big O of 1, so these are our overall time and space complexities, O of n squared for time, and then space is O of 1. Yeah, I hope that illustrates kind of the thought process and how difficult some of these problems can be. So realistically, if you use some tools like this and just kind of walk through it, you're going to get better at it. So